So next problem is based on uniformly varying load that we have discussed in the previous classes in the live class. So for the beam loaded as shown in the figure, determine deflection and shape function or shape. Also find the shear force and bending moment. Take E as 70 GPa and moment of inertia 4 into 10 raised to minus 6 meter to the power 4. So as I have already said that you have to take everything in meter to the power 4, I have converted this Young's modulus into 70 into 10 raised to 9 Pascal. So we come back to the diagram. So we have a UVL here 10 kilonewton per meter and 5 kilonewton per meter, and one more load or moment is there, that is 20 kilonewton per meter, which we have to apply for the force vector. And the distance between or the distance or length of the element is 1 meter each, and I have created the FE model. So one will be in the transverse and another one will be the rotational one, Q1, Q2, Q3, Q4, Q5, Q6, which we already discussed. And I have written the stiffness matrix, that is K. So we have two elements that will be K1 and K2, and I have written that values here. L is 1, E is 70 into 10 raised to 9, and I is 4 into 10 raised to minus 6. So I have multiplied it here, and I will write the value for that. That will be 70 into 10 raised to 9 into 4 into 10 raised to minus 6 divided by 1. That will be 2.8 or 0.28 into 10 raised to 6. So that is what we are getting. 12, 6, minus 12, 6, 6, 4, minus 6, 2, minus 12, minus 6, 12, minus 6, 6, 2, 6, 4. So I have written it here, and I will add both the matrix, that is K1 plus K2. Since both the matrices are same, I am writing it here itself. Don't get confused. I will write both the position values, that is 1, 2, 3, 4, 1, 2, 3, 4, again 5, 1, 2, 3, 4, and again 3, 4, 3, 4, 5, 6, 3, 4, 5, 6. I have just reduced the number of the writing. That's why I have written it same in the same matrix. So I will write a matrix of 6 cross 6. That will be K equal to 0.28 into 10 raised to 6. So you can either multiply it and then write adding it, or you can write it and then add it, whichever is okay. Better you keep it like that, and then afterwards we will multiply it later onwards. So I'll write the position values. That will be 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Here is the position values. So I have added all the matrices and written it. This is the K matrix, which will be the final matrix which you will get, and I have written the element load vector. This is only for moment. If there is a moment in any of the element, totally we are taking it as for 1, 2, 3, 4, 5, 6. We are combining it to 6 row matrix, which have only one moment here, so that is 20 kilonewton, and we have the same moment direction here, that is anti-clockwise. So we take it as positive itself, 20 kilonewton, 20 into 10 raised to 3. And the second part is about the UVL. So we have one UVL in only one element. So there is a different formula for UVL and UDL. This is for UVL. W1L by 60, 21, 3L, 9, minus 12, while W2 by L, W2L by 60, 9, 2L, 21, minus 3L. L is the element length. So element length is 1. And W1 is about the initial height, and W2 is the second height. So if the second height or the ending height is not there, this is a slant that touches the element, means you have to take it as 0. W2 will be 0, entire term will be cancelled off, and these things will be remaining. So if both are given, you have to take both and calculate the values. So I have written the force vector for UVL, that is minus 10 into 10 raised to 3, and this matrix, and minus 5 into 10 raised to 3 this matrix. Since L value is 1, we can multiply it 1 with 1, so these values remain same and these values also remains same. So I have calculated the values after multiplying each with each element and then added both elements, and we'll get these values. So we have to add this value. This is related to the first element, that is 1 2 3 4, and we have moment in a fourth one, Q4. We have a moment there, so this term, this is the fourth term, 1 2 3 4, this term has to be added with that moment. So that moment value is 20,000. So I have written it 1 2 3 4 5 6 force vectors. In that, moment has been added to the fourth force vector, so that this is the value what we have getting now. So now we have the element stiffness matrix, force vector, and also the unknown Q1, Q2, Q3, Q4 has to be found out. So what we have to use is equilibrium equation. Equilibrium equation is given by we all know that K Q equal to F is what we are using from the beginning. So I have written the K value 0.28 into 10 raised to 6, and this is the K term, and the Q term Q1 to Q6 we have written, and force vector from what we have got it here. So now we have to identify the boundary conditions. From here we can see that Q1 Q2 is fixed, and also there is no value in Q3, only Q4 is there, and also Q5 Q6 is fixed. So what we have to do is we do not have any fixed value here, that is Q3 and Q4 does not have any fixed values. So we have to fix the remaining things, that is Q1 Q2 and Q5 Q6. This has to be remained as it is. So that's why I have written Q1 Q2 Q5 Q6 is 0. So we have to cancel all those first row first column, second row second column, fifth row, that is fifth row and fifth column, sixth row and sixth column. So remaining things will be 0.28 into 10 raised to 6. So only remaining things will be this term, that is Q3 and Q4, 24,008 equal to this part Q3 and Q4 minus 3,250 and 20,583.33. So this you have to find using equation in calculator. So you will get two values of Q. So I have got two values, that is Q3 will be minus 4.83 into 10 raised to minus 4 meter, and Q4 is 9.18 into 10 raised to minus 3 radians. So this is two Q values which we have found and obtained. Next part in the question is about bending moment and shear force, which they have asked. It is direct formula, K into Q. We have found out the K value already, and we have the Q value. For the first element it is Q1, Q2, Q3, Q4. For second element it is Q3, Q4, Q5, Q6, like that. So I have multiplied it and I have written the answer. We can verify the answer, and also for this element 2 it will be SF to SF, BM2, SF3, BM3. For first element it is SF1, BM1, SF2, BM2. So I have multiplied it and got the answer. So this is the final answer they have asked for bending moment and shear force.